How we doing, guys? It is Thursday, April 30th. We are going to end 10.4 today and get into, once again, another kind of topic that you guys should have already learned last year in your Advanced 2 class if you were in it, something called the distance formula. So again, this should be a review. It should be pretty quick lesson, and then you guys are just going to do some practice on big ideas at the end. But essentially, we're just going to read the second sentence here, that we're going to be able to use the distance formula to find the distance between any 2 points in a coordinate plane. All right, so that's what we're going to be doing. As you can see, your learning target matches with that pretty well, that I can use the distance formula to find the distance between 2 points in a coordinate plane. All right. So let's get into what does that formula actually look like. All right. So key idea, the distance d between any 2 points of x1, y1 and x2, y2 is given by this formula. All right. So what that's saying is we can find the distance between any 2 points using this formula right here. So the distance between 2 points equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, and they give you a diagram over here of how this works. Okay, but yeah, we're just finding the distance between 2 points in a coordinate plane. All right, it's pretty simple as long as you do a specific step, which is labeling your ordered pairs. Okay, so when I say labeling our ordered pairs, I'm going to do the exact same thing that I did when we learned how to find the slope of a line. Okay, and I'm going to label my ordered pairs, my first ordered pairs, as x1 and y1. Then I'm going to name my second ordered pairs x2 and y2. Okay, once I label, I think that this is pretty simple because I'm just plugging those numbers into their variables accordingly. All right, so if we look, they're saying the same thing that I did. They're just showing it in a different way. Let x1 and y1 be negative 3, 5, and let's let x2, y2 be 2, negative 1. Okay, we're going to, well, they write out the distance formula, and then they're going to fill in everything accordingly. Okay, so here we go. If we look, x2 minus x1 is the first portion of our formula. Okay, so x2 minus x1. Now if we look, it's 2 minus negative 3, which we all know is really plus. Okay, squared plus y2 minus y1. Okay, so negative 1 minus 5. Negative 1 minus 5 squared. I want us all to remember the fact that when we square a negative number, like we will be, all right, it's not going to be a negative answer. Okay, it will always be positive. When we square any number, it will always be positive. Plus, it only makes sense that when we're finding a distance between 2 points, that we have a positive answer. It only makes sense. All right, so when we do the math, 2 minus negative 3 is really plus, so 2 plus 3 gives me 5. Negative 1 minus 5 gives me negative 6. So I'm going to square these two numbers. I'm going to get 25 and 36. Okay, I'm going to put them together, and I end up with the square root of 61. All right, now the book just kind of leaves it as that, which is fine. But if we actually wanted to evaluate that, the square root of 61, I always say round to the nearest tenth. All right, so if I took the square root of 61, I end up with 7.81. So rounded to the nearest tenth, I'm going to put approximately 7.8. Okay, so that's pretty much it. Pretty simple. Let's do one more example here. All right, so we want to find the distance between 1, -5, and 7, 4. So again, first thing I'm going to do is this. I'm going to label my points, and I just always pick my first ordered pairs as x1, y1, my second as x2, y2. Just kind of makes sense to me. All right, so let me see if I can fit this. I'm going to say my distance equals the square root of all of this stuff. So x2 minus x1 is the first portion of this. So I'm going to say 7 minus 1 squared plus y2 minus y1. So 4 minus -5. So right away I'm going to put plus. I'm going to put 4 plus 5 right away, because again I'm subtracting a negative. That's really addition. All right, so now my distance is equal to the square root of 7 minus 1 gives me 6 squared plus 4 plus 5 gives me 9 squared. Okay, I'm going to come down here. My next step is my distance equals, I'm going to square these numbers now. Okay, so it's the square root of 36 plus 81. So my distance is going to be 36 plus 81 gives me 117. So the square root of 117, which I'm going to take now on my calculator, 117 is 10.81. So rounded, I'm going to do this again. This little squiggly equal sign means approximately, because I'm rounding, about 10.8. Okay, so either of these answers work. All right, sometimes the book just leaves it as the square root of a number and that's the end of it. And other times they'll ask you to round it to the nearest tenth, the nearest hundredth. It just kind of depends on the instructions. Okay, but again, that's pretty much it. And as long as you label your ordered pairs, I don't see any reason this is difficult. All right, and I think you guys will feel the same way. Pretty simple stuff. You guys are all fully capable of doing this, especially with all the skills we've been learning with taking square roots and order of operations. So we should be pretty used to this by now, and it should make sense to you. As always, if not, email me with any questions or ask in the discussion thread. Just so you guys also know, I'm going to have all your grades in for your previous IXL assignments today. I was just kind of waiting on a couple of students to finish them up, and it's just so much easier to put everything in at the same time as opposed to having some late assignments come in and then emails about those late assignments. So again, all of your grades will be put in today, and we should be caught up. But again, hopefully this made sense to you. If not, ask me some questions if you need to. But otherwise, I will talk to you guys later.